Yes. Yeah, I think you can start once people come in.
Okay.
Yeah, we have some words that we can bring or get before or after the session.
Oh, that's actually.
Okay, I'll let people sit down a second.
No, I think it's the last. The black sheet, it's like the bottom of the. You guys want the songs? You want to be on the song?
We have more stuff. We have more stuff. We will bring after the session. Okay. After we finish the session.
And we have some t-shirts too.
Yeah, not a lot, but.
Oh, okay, but one at the end of the
Yeah,
session, yeah. Okay, so we'll go ahead and get started. So good afternoon, everyone, and welcome to this workshop that is titled Internet Computer Building Cross-Chain Applications. And that title may be a bit confusing because what does cross-chain mean? So before we get started, just a quick introduction to me. My name is Jessie. I'm a technical writer at Dfinity. Dfinity is a nonprofit foundation that is the primary contributor to the Internet Computer blockchain. And my background is in Cisco networking and Linux system administration. I actually worked here at MIT for a little while with the EAPS and Sloan labs doing the management of their high performance compute servers. So if you guys have any familiarity with TechSquare or that company that MIT works closely with, I was with them for a couple of years before I transitioned into technical writing. So that term cross-chain, what does that refer to? So let's take a step back and let's talk about blockchain. So you may have heard of this term floating around in the tech world in the past couple of years, especially around things like Bitcoin and Ethereum. What a blockchain is it's an immutable, public, verifiable record of data. All of the information on a blockchain is able to be publicly viewed by anyone and verified that it is factual, is correct, and it has been recorded honestly. And some of the big names in the blockchain space are Bitcoin, Ethereum, and Solana. On blockchains, we have things called smart contracts. And so whenever you want to deploy a program that uses the functionalities of a blockchain, you're deploying it in this smart contract format. Traditionally, smart contracts are immutable. Once you deploy them to the blockchain, they can't be edited or revised. So if you have a bug, you have to completely redeploy the smart contract, then you have a new ID for it, and then you have potentially breaking changes if other things rely on that ID. Decentralized applications refers to using smart contracts for some logic or data, but typically a decentralized application only has one aspect that is in fact decentralized. A lot of the times decentralized applications, especially ones built on chains like Ethereum, are storing some data somewhere off chain, typically in Amazon or DigitalOcean. And they do this for a number of reasons. Sometimes it's performance, sometimes it's cost. Other times it's things like if you have personally identifiable information, like things that need to be HIPAA compliant, you can't store that on the blockchain because then it's public and you can't be just broadcasting people's information like that. Another term that comes up a lot with blockchains is the term gas fee. And so this is the cost of deploying transactions on the network. Typically, that's going to be paid in the network's native currency. And then you're going to be using wallets of some form or fashion to hold that currency. And those are typically MetaMask, Coinbase, or anything that you can use to buy and sell cryptocurrencies. So one issue that we see a lot in the blockchain ecosystem is that you get locked into whatever blockchain you pick, you get locked into their ecosystem. So if you have an Ethereum smart contract, but you want to get some information about Solana, you have to use what is known as a bridge to kind of bridge the connection between those two. And that adds an additional layer that could be malicious, it could be dishonest, or it could be exploited. And the other aspect with having two chains talk to each other is that they typically use different languages or encryption algorithms, and then you have to do some transition from one language and encryption to the other. Usually smart contracts that are written in Ethereum can't be deployed on Solana and vice versa. Then the tooling is then, of course, going to be different as well. You're going to have one set of tooling for compiling Ethereum smart contracts, another set for Solana, and learning and downloading new tools every time you want to interact with a different ecosystem can slow development down. So insert the internet computer. So what is the internet computer? So we're a layer 1 blockchain, but we classify ourselves as a blockchain singularity. We're able to do everything on chain. So you don't have to store data on AWS or DigitalOcean. You don't have to outsource compute. You don't have to outsource any of the traditional pain points that you would have to when you're doing traditional blockchain development. We classify ourselves as decentralized serverless compute. And we have one of the largest research and development teams in the blockchain space that allows us to have a lot of unique in-house technology, including our novel consensus mechanism and our cryptographic algorithms. That allows all of our tech to be as compatible with other chains as we want it to be. So if we want to intentionally have the ability to communicate with Ethereum without a bridge, we can do that, and we do that today. And we have several applications that are doing that directly with Ethereum, Bitcoin, and then we have other integrations in the research pipeline right now as well. We're also the only chain that we're aware of that is able to run AI LLMs fully on-chain. So you can do on-chain inference, and you don't have to run things locally or have things outsourced to different APIs. Everything can be run directly on what we call canisters. So our term for smart contracts are canisters. And the other thing is that your canister can be written in any language. You don't have to learn our native language, Matoka. You can write in Python, TypeScript, JavaScript, Rust, whatever language, as long as it can be compiled into a WebAssembly module, you can run it on ICP. And then lastly, all of our smart contracts are upgradable. So if you deploy your application and you find out that you have a bug, or if you want to add a new feature, you simply push an update and everything stays the same. You don't have to then notify users to go to a different URL or update their code to use the latest hash of the canister. It's going to have the same canister ID, and it's going to be fully interoperable with anything that was dependent on it before. And so lastly, this term chain fusion. This is what we refer to our integration with other chains as. So it's just our ability to directly communicate with our other chains without a bridge, and canisters can interact with several blockchains within a single piece of code. And so that's going to be a piece of code that I'm going to demonstrate later in this workshop, how you can write a smart contract that obtains information from Ethereum, and based on that information, it's going to send a transaction directly to Bitcoin. So why develop on blockchain? So there are lots of other really interesting companies and projects here at HackMIT. Why should you pick a blockchain variation as opposed to a traditional tech stack? In addition to all of the other just native benefits of blockchain, it being verifiable, public, immutable. In the context of ICP, we are significantly cheaper than going with a traditional tech stack route. We are a lot cheaper than deploying part of your project on Amazon, than using a DigitalOcean droplet, than using some other front-end hosting. We have much faster performance. All of our code is open source, and you can deploy your front end and back end in one place. You don't have to manage two different deployments. You deploy one project and it has the front end and back end in one location. And then all of our smart contracts are publicly accessible on the web. So as soon as you deploy it to the mainnet, you have a shareable link that you can send to anyone in the world that's hosting the front end of your application. You don't have to configure any domain hosting, routing, any of the traditional stuff that comes with hosting an app. So a quick rundown of ICP terminology, since we've got some new terms that are unique to not just blockchain, but ICP in general. We refer to all of our smart contracts as canisters. We talk about decentralized applications as dApps. We talk about paying for gas fees in what are known as cycles. The term principal just refers to any entity on the network, a canister, a user, or any other asset you can think of. DFX is our CLI tool. Motoko is our native language, but you don't have to learn Motoko. You can develop in any other language. Internet identity is our off-the-shelf authentication and key management system. And then ICP hubs, who are the sponsors of us here at HackMIT, is our term for global communities that are specific to different regions. So we have tons of them all over the world. We have ICP hubs, North America and Canada, which is who we have folks here from today. And then we also have ones in France, Singapore, Bali, wherever you really can think of, we have an ICP hub community.
We have 40 ICP hubs across the globe. We are representing today ICP Hub Canada and the US, but as Jesse mentioned, we have the Asia Alliance, Europe Alliance, Africa Alliance, America Alliance, and yeah, we are welcoming to everyone, the developers, entrepreneurs, investors, DGens, and communities in general to participate. But yeah, we are all across the globe.
Yeah. So what is a canister? So I've got two cute little diagrams here for you to kind of illustrate what a canister is. The one on the left is a bit of a simpler breakdown of it. A canister is just code and data associated with that code. But then if you want to get a little bit more detailed in the stack, a canister is going to have both an input queue of transactions that are coming to it and an output queue of transactions that it's replying to. It's also going to have WASM memory, stable memory, WASM code, a balance of cycles that it can use to pay for its resources, its own bit of settings, controllers, etc. So typically on ICP, the developer workflow looks something like this. The kind of TLDR of it is you're going to write your canister code, and then you're going to use DFX to create an empty canister. You're going to compile that code into a WebAssembly module. Then you're going to install that WASM module into that empty canister, deploy that canister either locally or on the mainnet, and then interact with that canister however you intend to, whether it's making calls to query information about things on chain or off chain, or if you are using the canister to simply host a front end static website, then you would just simply open the canister URL in a browser and you'll have that website available for you to use. So one thing about developing on ICP that if you are interested in, you will need to be aware of is our reverse gas model. So typically on other chains, users are paying for the gas fees whenever they interact with your application. So if you've ever used a Web3 application, you typically had to go on, use MetaMask or some other wallet, and then pay for the transaction yourself if it was minting an NFT or transferring a token. On ICP, developers pay the gas fees on the back end. And so this results in a much more seamless user experience. Your users don't have to know anything about crypto or blockchain to use your application. They interact with it like a traditional Web 2 application. And that is really great for user experience, but it's also good for the ecosystem and onboarding people into blockchain in general. If you're able to provide them with applications that look and feel like Google and Facebook, but in reality on the back end, they're using blockchain tech. It's really great for just overall onboarding into Web3. And a question we get a lot is how much does it cost? So for a quick benchmark, if a canister is storing about 5 gigs of data, it's executing about 50 daily tasks. Those tasks could be just querying information from the network. And if each task has about 1 million instructions, it's going to cost you about $2.11 a month. So extremely cheap in terms of application development when you get into paying for all of the different subscription services that come with AWS and DigitalOcean and all of those options. So we have Cycles coupons here for HackMIT, and there's more information about this in the Discord channel for the ICP Hub sponsor. But we have coupons for 10 trillion cycles, which is enough for deploying a front end and a back end canister. And we recommend that you don't deploy to the mainnet until you are ready to publish your app, since that's going to be the portion that costs cycles. Doing anything locally is free. It's not going to cost you any cycles to deploy locally. So let's start building something, shall we? So first, we're going to need to install DFX. And so this is going to be our CLI tool that we use for building canister smart contracts on ICP. It's your one-stop shop for creating, deploying, managing, anything you want to do with a smart contract, you can do it through DFX. By default, it supports the Motoko and Rust languages, but it also has template options for our community developed kits called Azel and Kybra. Azel is for TypeScript and Kybra is for Python. Both of those have a few bits of prerequisites that you will need to do before you get started if you want to use either of those. And then if you are on a Mac system, you'll also need to have Rosetta installed. So just a few installation notes. And I already have it installed, so I won't bore you with curling the installation and going through that. But now let's go ahead and take a look at creating a new project. So if I go ahead and open up my terminal, I'm just going to do DFX new hello, and hello is just going to be the name of the project that I want to give it. And now I'm able to choose which language I want to write the backend in. For this example, I'm going to showcase Motoko, since we are big Motoko fans at ICP, since it's our native language. But like I said, you can develop in any of these 4, or we have community kits for a lot of other languages like C++ as well. And then for the front end framework, you can select any of these templates, or you can bring your own front end. For this example, I'm just going to select React, since that's pretty popular in the industry right now. And then we can also add additional features, but we won't do any of that today. So it's going to take a second just to go through and create all of the default template files. This is just going to create 2 smart contracts. One is going to host all of the front end assets, and one is going to host the single source code file for the backend. And we're also going to get some links to some of our docs and instructions on how to get started. So if we just navigate into the hello directory, and then if we just want to take a look, for example, at what we have for the backend, we can do hello backend, and it's just going to have that one main.mo file. And then if we want to take a quick look inside of that, we are going to see that Motoko uses an actor-based format for programming. So we're going to define a single actor in our canister, and then we're going to define one function. This is going to be a public function, so anyone can call it. It's going to use the query method, meaning that other canisters can call to this and query the result of it. And then we're just going to call it greet, and it's going to return hello, and then it's going to insert whatever text we pass to it. So let's take a look at going through and deploying this real quick. So if we just use dfx deploy, this command is kind of a catch-all command for dfx. It's going to go through and it's going to compile the code into WASM. It's going to create those empty canisters and then install that WASM code into those canisters. And then it's also going to generate a couple other files for what we call candid, which is our interface description language, but we won't get into the details of that. For this, we'll just go ahead with dfx deploy and it will do all of the heavy lifting for us. Oh yeah, do we have any questions so far?
It's operating any EVM application like relating Solidity.
Yes, we do have a community project for Solidity. Yep.
And the BASM will be stored in bytecode or it will be like
I think it's bytecode, yeah. All right, so now we can see that we have a couple of URLs here. So this front end one, we've got two different formats. This is just going to depend on the routing for if we were doing something with the domains for that. But for this, we're just going to open the first one. And we can see that here is our front end of our application. It's already hosted in the web browser, and it's just a simple form for us to enter a name. And so I can go ahead and enter my name and click on the button, and it's going to make a call to the backend, query that greet function, and it's going to return hello and then the name that I inserted. And then we can do HackMIT, and we can see it returns HackMIT. So now back to the presentation. So we also have options for deploying these through GitHub code spaces. So if you don't want to download any of the tools or do anything locally, you can use the GitHub code spaces workspace that comes pre-installed with everything you need to get started. And it comes with this Hello World template installed. And then a quick overview of the project's default files. So like I mentioned, the backend canister just has the source code for the backend, and then the front end has whatever components you want to be part of the front end user interface. So if you had any photos, videos, if you had a marketplace and you had images of different things that you had for sale, those would be stored in that front end canister. And then the back end canister would store any of the logic for the marketplace. So if you had code for listing an item, for when an item is sold, etc., all that would be in the back end. And then deploying the project locally, we went through and we did that, but as just a quick summary, dfx deploy did all of the heavy lifting for us. It set up a cycles wallet for the canister so that we can give it cycles if we want to deploy it onto the mainnet. And then it also sets up the canister with the WASM code. It compiled that code for us and set all of that up. And then it also did a couple other things that we won't dive too deep into, but there are some details here on this page if you're curious about that architecture. And I will have a QR code at the end for this presentation if you wanted to reference this presentation later and dive into the details a bit more. And so we took a look at that default Hello World code. And like I said, it's written in Motoko. And so why would you want to use Motoko? Why bother learning a new language? Motoko is meant to be a general purpose programming language, but it was designed specifically to author ICP smart contracts and utilize ICP's unique features and architecture. It is designed to be approachable for programmers who have some familiarity with object-oriented or functional programming. So if you have experience with JavaScript, Rust, TypeScript, etc., it's designed to be pretty familiar in that regard. It uses an actor-based model, and it also uses orthogonal persistence for simple, safe, and efficient data storage. So going back to that term chain fusion that I mentioned in the beginning. So chain fusion is ICP's fancy way of saying we are able to interconnect with multiple blockchains in a decentralized manner, eliminating the need for any third party like a bridge or an oracle. This is made possible through ICP's decentralized bidirectional communication with ICP and other chains, allowing smart contracts deployed on ICP to sign and submit transactions directly on other chains. It gives a Web 2-like user experience. It's highly performant. Everything is able to be stored on chain, and it has interoperability and autonomy as well. A quick overview of our Bitcoin integration. So our Bitcoin integration is what we call a direct integration. This means that nodes on our network are running their own instance of Bitcoin. And so we are able to have smart contracts that are deployed on ICP communicate directly with these nodes. And we use some unique in-house developed cryptographic signatures called threshold ECDSA and threshold Schnorr. This just means that they're our versions of ECDSA and Schnorr, two forms of cryptography that are used by Bitcoin. And then the Bitcoin adapter just refers to our subnet of nodes that participate in Bitcoin. Then when we talk about Ethereum and other chains, this includes any EVM compatible chain. We still use that unique cryptographic threshold ECDSA protocol, but instead we're using HTTPS outcalls instead of a direct integration. So none of our nodes on the network are running Ethereum or any EVM compatible node software. Instead, we are having our smart contracts make calls out to the rest of the world. So this isn't specific to Ethereum or EVM. This can be to any Web 2 service. So your smart contract on ICP can obtain information from any API that is Web 2, Web 3, whatever it be, it can obtain it if it's not on the network. And so we are able to use that to communicate with JSON RPC services that query information from Ethereum, and then we query that RPC service and we're able to get information about Ethereum. And then that's also what allows us to sign and submit transactions directly to Ethereum and other EVM chains. Some other chains don't use threshold ECDSA though. They use either threshold EDDSA or other various types of cryptographic signatures. We do have plans to support most, if not all of them. And specifically, we have plans to support Solana, Cardano, and Polkadot in the future. And all of these are on our roadmap. So now let's take a look at how we would edit Hello World to use Chain Fusion. So we are going to go ahead and we're going to open up our project, this time in a code editor. And I'm just going to be using VS Code. And I'm just going to open up that Hello project. And going into the backend code, we can see that it has just that simple Hello World greet function. And so if I want to make this now use Chain Fusion, first I'm going to take some import statements to import a couple of different things that we're going to utilize. So first we're going to import the EVM RPC canister. We're going to import the IC management canister. This is going to allow us to submit the Bitcoin transaction. And then the last two are imports for Matoka. One is the cycles library and one is the debugging library. And so then I'm going to just copy and paste this real quick and then explain it a bit more. So here we are defining the actor for our canister. So every canister can only have one actor if it's a Motoko canister. And so we're going to define that actor. We're defining a variable that's going to store the Bitcoin fee. This is going to be in cycles of how much it costs us to send that transaction to Bitcoin. And then we're going to define a public function called getLogs. And this is going to make an RPC request to the Ethereum mainnet through the public node RPC provider. This call to Ethereum is also going to cost cycles, so we're going to add cycles to it as well. And then we will define the details of the RPC call itself. So we want to call the ETH getLogs RPC endpoint. We're going to include the services, so that's going to be the definition of the mainnet and the RPC provider. And then we're also going to include exactly what information we're querying. So we're getting logs, but what logs? And so in this request, we're going to get logs specifically for this Ethereum address at this block number. And then we want specifically these transactions. So these are all transaction hashes. And so then the second half of the code is, now that we have the RPC request, what do we do with the result? So we're going to process the results, and if we have a okay, we were able to receive the result successfully, we're going to send the send Bitcoin function. And so then lastly, we just define that send Bitcoin function. It's just going to attach cycles to the call, and then it's going to call the Internet Computer's Bitcoin send transaction method. And then here, this transaction, for the sake of time today, we aren't going to dive into creating a Bitcoin transaction and signing it. So this is just a placeholder hash. And then here we are also defining which network we want. And for this, we'll actually use the Bitcoin mainnet instead of the testnet. And so if I go ahead and save this file, then I can go and use DFX deploy to redeploy my smart contracts. But first, there is one other thing we have to do. So we aren't using the front end canister now. And instead, we're importing this EVM RPC canister. And so we need to go into the configuration file for this project, this dfx.json file. And we can see that it defines in this canister section, it defines the backend canister and the front end canister. We're going to remove the definition for the front end canister since we aren't going to be using it. And we're going to insert the definition for the EVM RPC canister. So now when we go ahead and redeploy this project, it's going to upgrade our backend canister since the code for that is changed. And it's going to deploy that EVM RPC canister for the first time. And here in the EVM RPC canister's configuration, it's pulling the candid file, which is the interface description file, and the WASM module, both from GitHub. So it's being told to pull them from a different source. It's not going to look for them locally. So now we'll do DFX deploy. And we can see that it is creating that new EVM RPC canister.
Is there a place you can find this code?
Yes, so I have a GitHub repo with it, and I have the QR code at the end of this. And like all good live demos, of course, I have an error and it's not happy with me somewhere. And that's what happens when you copy and paste things. But that's okay, because that's exactly why I put the working one up in GitHub. And I have this one to copy and paste from. Oh, it would help if I copy and paste it in the right file. Okay. And so here it's going to ask us for an initialization argument. This refers to the EVM RPC canister. It needs to know what size node subnet it's being deployed on. And since we're just deploying locally, we're just going to use the value 28. And we have docs that go into detail about the EVM RPC canister and why you need to specify that and all that good stuff. And I also have links to all of that in the GitHub repo. And so now if we take a look at the backend canister, this is only going to be accessible through the Candid UI. And so Candid is a language that we use to describe the different interfaces that are available in a canister. So here we can see the two functions that are defined in our canister, the get logs function and the send Bitcoin function. We can interact with them directly through this UI, or we can interact with them through the CLI and make calls directly to them. But for this presentation, we'll use the Candid UI and click on the call button. And so if this works as expected, so this is, it's not finding the canister for the Bitcoin integration. And so that's expected since we didn't deploy it here locally. We only deployed the EVM RPC canister and the backend canister. So if we want to use that Bitcoin canister, we'll need to deploy to the mainnet. So if we use DFX deploy network IC, that'll tell it to deploy it to the mainnet. And then this canister that it couldn't find will be available on the mainnet. And
the OSP is possible to access like a mainnet transfer for the testnet, like if you had something like that Bitcoin like service that's only in mainnet, could you call that from testnet, or would you have to be on mainnet for that?
so we don't have a testnet, so no, you wouldn't be able to call it. If we had a testnet, there might be a way, but since we have HTTPS outcalls that allow our canisters to call anything outside of the network. So if it was located on a testnet that was on the web, we could call it through that, but we don't have a testnet like Sepiola or some of the other popular ones in the blockchain space. We have our local environment, and then we have a sandbox environment called the playground, but the playground is restricted in what you can do, and HTTPS outcalls are one of the things that are restricted in the playground. All right, let's try this again. Okay, all right. So now we are on the mainnet. So this is our public mainnet canister ID. So anyone in this room right now can go to this URL and see this live on the internet. And so now, since we're on the mainnet and we're able to call the Bitcoin canister, this should return an error still, since we didn't put a real Bitcoin transaction in the code, we just put a placeholder. We should get a malformed transaction error, but that shows us that we were able to call Ethereum, return the logs from Ethereum with a success result, and then fire off the Bitcoin transaction in one single piece of code. And so, yep, we see that malformed transaction. And so that's exactly expected, since this value BEEF is not a real transactional value. But so that's just a couple of lines of code, just 63 lines of code that show how you can be on one blockchain on ICP and have a canister be able to seamlessly communicate directly with Ethereum and Bitcoin in one piece of code.
Can we see these transactions on Mail, like Explorer or something?
Yeah, so we could yeah, so we can go onto the IC public dashboard. And so this is our public canister ID. And we can go over to the canisters tab. And actually we'll go to search. And we'll put in the canister ID. We're searching for a canister. And so here we can see all of the public information about the canister. We can see the controllers of the canister. So these are the identities that are able to make changes to the canister. We can see the ID of the subnet that's been deployed on, and then the hash of the WASM module. And then we can also take a look at exactly what methods it has available to call. And it looks like I don't have the transactions here for this one, but that is also possible, the fact that it didn't actually write any new transactions. All it did was query a transaction from Ethereum and get the result back. And then if it had submitted that transaction to Bitcoin, we would have that transaction information. All right, and so like I said, I have the GitHub repo for this project if anybody wants to download it and play with it. The one that I just used to deploy does work, but the one that I copy and pasted from the presentation doesn't. That's okay. And this presentation is also linked as a QR code in case you want to review any of the information that I went over. Some of the slides, I didn't go into super detail on some of the fundamentals. There is a lot, when you get into ICP, there is a lot of initial learning since we tried to do blockchain different. And there are lots of terms that, like I showed at the beginning, are unique to ICP. And then since we have such a huge focus on research and development in-house, a lot of the ways that we do things are unique and new and just come with their own learning curve since they haven't either been done before or done in the same way that we do it. Does anybody have any questions?
It's probably super out of context, but what's like the coolest use of IC that you've seen so far?
Yeah, we have a lot of really awesome ones. The first one that always comes to mind is called Open Chat. It's kind of like Discord, but you can do directly in the application. If you have a DM chat with a friend, you can directly send them crypto right in the app. And so you don't have to connect a wallet. You don't have to go to a different service. Like if you today go out to dinner with a friend and you want to split the bill, you both have to go to Venmo or Cash App and send it. With Open Chat, you can have the conversation to make those dinner plans, and then later at dinner, send CK-USDC, which is just our own version of USDC, directly in the app and say, okay, here's the portion that I owe you for dinner, and then continue to have, your conversation with that friend directly in the app. And it's set up very similar to Discord in the fact that it has like different communities you can join. Each community has a set of different channels. And then it recently started to support video conferencing as well. And so all of this is deployed on chain. None of it is outsourced to Amazon or anywhere else. It's all deployed directly on blockchain. So that's one. And then we recently just had a really exciting project kind of take over all of the ICP community focus. It's called Bob.fun, and Bob stands for Blockchain on Blockchain. And so they've essentially created a layer 2 on ICP. And you go on there, you deploy miners, and you have them mine the Bob token. And then if you get rewarded a Bob token, you convert it to ICP, and it's its own kind of mini challenge project. And everyone's starting to jump on it, and they're just impressed by the performance that they're able to get. It uses proof of work. So proof of work is the consensus mechanism that Bitcoin uses, and Bitcoin's finality time for it to mine a block is pretty slow in comparison to the normal internet. And so this Bob.fun project is showing how you can implement a proof of work consensus on top of ICP and have the finality time be a fraction of a second instead of on Bitcoin. Sometimes the finality time is up to 10 minutes. So it's just kind of really showcasing how far you can push the tech that's on ICP. And then we have a bunch of AI projects that are starting to pop up. Like I mentioned, ICP is the only chain that you can deploy a full LLM on. And so we're seeing people create not just your traditional chatbot and image inference things, but we have one project called Elna that is a marketplace for chatbots. And so you can write a very specific chatbot that's running entirely on chain, that has all of its learning information on chain. And you can say, I want it to act exactly like Homer Simpson, and I want it to be his personality and his humor, and I want to have the entire information of The Simpsons, and I want you to be able to ask it anything about The Simpsons, and it will, give you that. And then you can make that and train it and then put it up on this Elna marketplace. And if somebody has a use for a Homer Simpson chatbot, they could buy it, and it's already trained and configured exactly how they want it. And so there's lots of people that are turning that into a hobby where they're going on and they're making very specific chatbots for things like healthcare, all sorts of different utilities that, why go and create another, Chat GPT for a specific thing. Instead, you can go on LLM, you can buy a variant of it, and then now you have it, you can move on with your project or your business or whatever your need for the chatbot is. You didn't have to either go and train one yourself or go and give the prompt to somebody. You can just browse this marketplace and find something for it. Yeah.
I'll have to ask you more about that video conferencing thing. I'm kind of curious on how that works. But
Yeah. Oh, yeah. They recently upgraded it. At first, when they first launched it, they only supported 20 participants in the video call, but they just upgraded it, I think, on Thursday to 200. So you can have 200 live video chat people running in this application that everything's on chain. All the video is saved on chain. Yeah, it's the open chat team they are definitely next level. They're by far the biggest project that we get initial adoption with, because it looks and feels just like Discord or just like any other. Yeah, it feels very familiar. It looks very familiar. The only bit of difference is that you log in with an internet identity. So that's our format of MetaMask, if you're familiar with MetaMask, or it's just basically our Web3 identity that you can then take to any other Web3 application that wants to implement internet identity. So it's kind of like Google SSO login, but Web3. So any app can implement it. It's fully open source. Of course, we primarily see its use in apps that are deployed on IC, but it doesn't have to be IC. Any open source product could take internet identity and implement it and use it as an option if they wanted to.
Also, maybe we can access to the website, internetcomputer.org, and check the ecosystem.
Yeah, yep.
Yeah.
So
Let's see what clarity about all the projects that you can meet. You can meet anything you can imagine, to be honest, on ICP right now.
yeah,
DeFi, DAOs, social media platforms, video games. Yeah.
yeah. So these are, and this list probably needs to be updated more regularly than it is, but because there are just new projects every single day. Like, for example, I don't think Bob is on here yet.
Yeah.
But yeah, we have all sorts of different use cases, and
We have guys like $2,000 in prices. We don't expect, like normally like people coming here, like 100 people, and then it's difficult. It's not the easiest maybe project or blockchain or system to deploy.
Yeah.
And you have a huge opportunity here, right? Because yeah, if you can build something normal, like cool in 24 hours, of course, it's also like rewarding. And then we have as well like Quantum Leap Labs is the incubator, the official incubator of the ICP Hub Canada in the US. And we are also offering some grants as well as support, to build your project totally on chain, right? We have weekly calls, we have different classes in tokenomics, in the legal as well to understand what is a DAO as well, canister smart contracts, how to deploy on ICP, all the marketing stuff as well. Yeah, it's pretty cool. The opportunities are there, guys. But yeah, that's really cool. Thank you, Jesse. Not sure if you have any other specific question related with the technical things or deployments.
I wanted help with my project.
okay, yeah, I can definitely help you.
Yeah, we will be here like today and tomorrow. Also, we have in our Discord channel another 4 guys that is helping us. If you have any questions, I'm not the technical guy, but we have here this is really good. Feel free to ask any questions.
And we also have tons and tons of sample code. So we have tons of like starter projects that are meant to do kind of similar to what I demonstrated, that kind of shows you how to set things up and then kind of gives you the keys and says, okay, figure out where you want to go from here with this. And if we don't have a sample project for a use case that you're thinking about, chances are we have a ecosystem project that might be similar. And most of our ecosystem projects are open source. We do really try to recommend that everyone open sources their code, since then it can be audited and verified by the community and just gives another layer of trust to everyone that's looking at it. So most of the time, if you have a use case, we can probably point you at some open source code that can help demonstrate a specific workflow or get you part of the way there.
Any other question, guys? Yeah, okay, yeah, anyway, yeah, we have our Discord channel if you have questions, or here we have Jesse as well. Yeah, thank you so much, everyone, for your time.
Yeah, thank you guys.